Hi, I'm Sarah Hoagate. I am a biology student at Cecil College. Today I've brought a fluorescent microscope to show you guys. It's the newest addition to the science department, and it's a really fantastic one. You'll notice that I'm wearing my PPE, which is abbreviated for personal protective equipment. And that's my gloves, my goggles, my glasses, and my apron. I'm also wearing closed-toed shoes, and you won't see any food or drink in this lab, and that's to prevent contamination from occurring. We're also dealing with a stain that is potentially carcinogenic, but since we're wearing gloves, we don't have to worry about that. Viruses are very small, so you can't see them using a compound microscope, which is probably the one that most of you have seen. That one, the light shines up through the bottom and through the specimen, and gets captured and shown out usually through bifocals, or some of them have LCD screens as well. This one actually uses a stain that absorbs the shorter wavelengths of light and emits the longer wavelengths of light. And that stain is actually antibody that will tag, or that's been tagged with fluorescence. So what you're looking at when I pull up the image is not going to be the virus. It's going to be the antibodies that have stained the virus. To start with, we have a parainfluenza virus. It's stained with an immunofluorescent stain, and basically what that means is you're going to see the virus without actually seeing the virus. The parainfluenza virus is not flu, it's not influenza. It causes a respiratory illness in young children and people with lowered immune systems, but you'll find it arise in the spring, the summer, the fall, whereas the flu, you'll see it in the winter, and only the winter. The stain itself is a bunch of antibodies, and those antibodies are tagged with a fluorescent stain, or with a fluorescent tag. And basically what that does is it allows us to see the virus without actually seeing the virus. So to start, you don't want to have this box on, because you need to use the compound light, the transmitting light. That's where the light just is going to shine up through the bottom, so we can get an idea of where we want to be. Also, you're using ultraviolet light, so you don't want to look directly into it. You want to be very careful with that. This looks like a good spot to be. Then you want to focus your image. And then you want to put this on. This will keep it, this will block the UV light from coming out, and this will also create a dark room so that we can do the microscopy with the lights on. And you want to switch to your DAPI field, DAPI. You want to make sure that you're as focused as you can get. Down here, and you hit capture. It'll turn the light off after it captures the image, and that's to keep from photo bleaching, so it won't destroy the virus or hurt the stains or anything. You want to switch to your GFP field. Turn your light back on. Find your image, fine tune it. It should be just about focused. And go back down and hit capture again. And switch to your RFP field. And do the same thing. Right on. And capture. Once you've captured the images on those 3 fields, you're going to come over to overlay, which makes for a very, very interesting picture that you can come down here and adjust until it's exactly what you want it to be. And there's your parainfluenza virus. Now, like I said, you're not actually looking at your parainfluenza virus, you're looking at the antibodies that have tagged the virus. So you can still see the shape of it, you can still see everything about it. You're just looking at the antibody, you're not looking at the virus. This is great for use in any type of medical field. This is pretty much what they do a lot of diagnosis with. Biology students at Cecil are going to be very excited to see this in a classroom. And you can also look at other things. You don't have to just look at viruses. You can go in, you can look at bacteria. Actually, a professor at this college stained some cells. She stained it with a 2-part stain. One part was specific for the nucleus. The other part was specific for the actinotubes. And the actinotubes are what help the cell to move. And obviously the nucleus is the powerhouse of the cell. So once she took the image in the DAPI field and in the GFP field, she overlaid them, just like I did with the parainfluenza virus, and she came up with this beautiful picture. So as a biology student here, I'm very excited to see this edition. I'm very excited to work with it. And I hope you all enjoy it as much as I do. Thank you.